Almost forgot that. All right. Sorry about that. Turning it over to Andrew Rogers.
Hey, so I'm Andrew Rogers with AceLOT Solutions. I think I've met most of you one way or the other at VOLTTRON events, etc., or on phone calls. Jeremy asked me just to kind of give a little overview of how we use Grafana to visualize some of the data we get back from our deployment with the city of Washington, D.C. I also just got back from a Grafana conference, and so it was really seeing some of the cool stuff coming up on the horizon with Grafana. So we've put a little bit of work lately into some alternate data interfaces to the backend data system we use, which is CrateDB, that enable a little more terse and expressive query language that also is designed around time series data, and specifically a very large number of the folks who use Grafana use this particular query language and data format. So the tooling tends to be a little bit richer. If y'all have seen Grafana, I don't know. I'll kind of just give a walkthrough of some of what Grafana can do. Its background was in monitoring systems for IT infrastructure. So looking at application load, server load, et cetera, over large operating infrastructures like some of the initial work I think was done around eBay's workload, and then a lot of other companies have contributed to making the interfaces better. I'll also say that one of the takeaways from the Grafana conference was there seems to be a pretty big swing towards folks using Grafana for more physical systems. So we saw some non-VOLTTRON related stuff with energy and disconnected mini-grid sites in Africa. So monitoring some of the infrastructure there for storage and solar systems that they're deploying in like shipping containers in villages, all the way through to monitoring ambulance, EMS activity, dispatch, real-time vehicle tracking for some cities in Australia. So it really does, it's a really great framework for building out a number of different interfaces in a number of different domains. The things that it kind of gives you off the bat are some query builders, some alerting functionalities, some alarming, that sort of thing. Basic functionality. It's not a tool that you will typically implement, high-end statistical analysis or some sort of anomaly detection. A lot of times when people do have anomaly detection as an infrastructure using Grafana, they will process raw time series streams through some algorithm in a streaming platform, an event-driven platform, and then generate an output time series back in their main data store, and then they can provide a visualization interface for that anomaly detection, but doesn't really have any of the analysis happening under the hood in Grafana. This is just some basic HVAC data in a kind of typical trending interface that you would see. You might would even see something like this in a regular BAS. So it's nothing real groundbreaking here, and all this is coming from one site, essentially one BAS, and we're looking at, in this case, I think mostly around the delivery of heat. So we've got these heating valves in our I'm not sure if these are air handlers or room units. I'd have to look at the other metadata to figure that out. But you've got some zone temps that are being affected by this, and then you've got the water loops themselves that are running off of your whether you're chiller or boiler systems. So this is kind of a very general HVAC use case of, hey, I want to know what's going on in my system. I want to, I've got a customer calling me and they're saying that this particular space is not, not within spec, and I want to know, what's actually going on there, what's going on with the equipment that's feeding that. And off the bat, you get really rich, like the ability to isolate particular data points like this. So I just want to see those 3 values. Well, all those valves are completely closed. That's not very interesting. You have this like hover tool functionality that shows you the values for the legend with the values as you hover over time. So as you move down the y-axis, those values will change. You also have some options where and sorry, I always have to look this up. Mod O, I thought that's what I did. There we go. So it'll actually track your crosshairs across multiple visualizations at the same time and show you data. So if you have, for instance, if you had a dashboard pulled up that was looking at the entire energy flow for a particular space, you would not just have to like estimate by the grid. You can actually use the crosshairs to identify exactly the correlation you want to look at. Yeah, there. So this one doesn't bring up the legends, but just moves the crosshairs. If you can see that, the line along the y-axis. So this looks like this is our interface and the query language we use. So we're saying for a particular site, give me all of the points that are tagged as heating valve output. So pretty simple query language, not a lot of like, it's a little bit, it's a little obtuse to know all the syntax, but once you know it, it's very concise compared to something like SQL, where you end up with a lot of boilerplate just to get to some simple filtering. And this is what like building a dashboard, graph by graph, visualization by visualization would look like. We also get some things in Grafana that are really nice around templating. So with templating, we can query our database for a particular type of value and then generate graphs and visualizations interpolating that value. So in this case, if we look at this first graph here, it's the only one that actually has sorry, I just saw the Zoom icon flashing, so I'm not sure if that was a chat or something coming in. I didn't hear anything. Nope. So it's the only one that is actually programmed. So in this, well, I'll show you the templating variables first. So settings for this particular dashboard, we can go look at variables, and we have this variable site that you can see here. It is querying any site that has a point ID expanded tag, and then we run a regex on the return to give us exactly the site name. So this is a preview of the values that this template tag or variable, template variable has available. And then when we build a visualization, we can say for each of those values, create this visualization. So we are only writing one query, and then in here we put that template variable here as a part of our query, and then obviously we can select the different types of point IDs from this list here. So the other template variables will just show up as a list you can select from for particular, in this case we're looking at the various in our particular tagging schema. Point ID expanded is essentially like a human readable form of a data type for equipment. And then area served is going to be the actual ID of the space that particular equipment is associated with. So when you go back to the dashboard, you see that we get this same visualization for every site that is in our system that has these particular tags. Of course, we have the same data quality issues that everyone else has. So I'm, pretty good chance that this space temperature that's at 52 and has 0 fluctuation is a bad sensor. Same as this space temperature that's at 120 and fluctuates all over the place is probably is probably a bad sensor as well. But that's also part of the value of these types of visualizations and having these data flows is to identify bad sensors and generate tickets to replace them. So that's a little overview of templating variables. Go ahead.
Real quick, you mentioned alerting.
Yeah. Oh, yeah. So there is a limitation in Grafana right now, because Grafana started as essentially a JavaScript application that ran in the browser. It didn't have alerting initially because that would imply that you had it had to be running in somebody's browser to generate alerts, which is not very valuable. So they have implemented now in the server, which is written in Go, that's actually hosting this and providing the authentication and then the other sort of nice things you get when you have an actual server running it instead of just a collection of JavaScript files. That's where the alerting engine is implemented now. The problem with that is it doesn't understand the template tags the same way the front end does. So when you have a set of graphs like this or set of visualizations like this, it does not know how to process those template tags. So if you're going to have an alert, it needs to be on a single flat query. So we can go back to this one that shows a single query. And we can go over here to alerts, and we'll see how to build the logic here. So generally, you don't want to query, you don't want to alert on a single anomalous value. So they have, well, like I said, you're not going to be doing heavy statistical analysis. You do have some nice, built-in features like average, and I think you can even get, depending on the data source, you can get things like median or other things other types of aggregations you might want to alert on. And then you typically give it a time range, right? So I want the average over the last 5 minutes to be my trigger, so that a value has to be at a certain threshold for a certain amount of time. And so here we would say pretty confident we're not going to generate a bunch of nuisance alerts by setting this to 120%. And so you can run a test rule. So that will actually take the data that's currently there, run it, and say that the interface we're using doesn't implement an average function. So you get a 500 from the data source. But normally this would pop up and tell you, okay, this is the data we got. This is the value we computed with the aggregation you gave us. And it's below, right now, it would be below the threshold. There are 0 values reporting above the threshold. If it was you set the threshold lower, it would say, oh, there's these 10 values are reporting above the threshold. And the nice thing you get when you do that, we come back out here. Now we have a threshold bar in our UI that shows us where that threshold's at. And if there's something over it, it would light up and show us that there's an issue there. We also get this little heartbeat or heart symbol next to the visualization name to let us know that there is a alert associated with that visualization.
Okay.
And then I'll show you one more thing that I think is a really powerful feature for sort of general purpose. I don't sell Grafana as something that is the end-all be-all tool for understanding how your HVAC system is operating or whatever system you've got is operating. It's a very good tool to get in and dig into real-time streaming data. It may not be your normal operator dashboard that you want to have, but it's a great thing for technicians to have available or engineers to be able to dig in. And then what I think that one of the powers that I think is really great that it brings is the ability for folks from across an organization to communicate the same data. So if you have a technician who is working with even an external vendor to resolve an issue, and you find something really interesting, and I didn't show this, but this is, pretty typical in visualization software now. You can click to zoom in, all the normal like fun features. You have a lot of options. I'll walk through this real quick too. A lot of options on how you show the data, how the axes are scaled, whether that's automatically or you can impose limits on the an axis, so that if you do have a bad sensor that goes to 5,000 degrees, like that doesn't make it to where you can't see the rest of your data, etc. But one of my favorite features is this share dashboard functionality, and this is one of the things that having the server gives us the capability to do now. Is we can actually create a link that will imply anyone who has the link has permission to access it, and that's through the snapshot functionality. And we can take that, it's going to take a snapshot of the data as it is now, fixed in time, and it's going to give us a link, and I can send that link to anyone who can reach the port I have Grafana listening on, and they're going to be able to see that particular set of data. Now, and it's this and it does it in such a way, like I only sent that one visualization, and it loads the dashboard. It doesn't load any data for the other visualizations. So you can share even, sensitive data this way, or fairly sensitive data. It's not actually access to your real dashboard. It's only access to the data that you've encoded in that particular snapshot, which is really great for communicating and making sure that, what your technician's seeing is what your engineer is seeing, is what your vendor's seeing, is what, the scientist is seeing if you're working on a research project. So I really love that feature. I think it's very, very powerful. It also has the ability to take any given visualization you're looking at, and this is very handy for, I guess, scientific applications where you might want to open it in a statistical analysis tool or something. You can take any one of these and actually export a CSV of that data, and you can pick what type of timestamp it uses, etc. Takes a pretty standard date time format string, and then not sure if it's gonna give me access to that. And so that's not, there we go. So here's oh, you probably can't see that, can you? Let me switch what I'm sharing. And so there you have an actual raw data export from that graph with the data in the visualization as a CSV.
Cool.
So if you want to run additional analysis or whatever. I think that's about all I have. Any questions?
So is that something?
Andrew?
Oh, go ahead.
Hey, Andrew, it's Nigel from SCS. I was just wondering, at the beginning of your presentation, on your home screen for Grafana, you had a Plotly panel, like a Plotly icon. I was just curious if you could talk about that.
Yeah, so there's a company called Natel Energy that builds a novel hydroelectric product for ecologically low impact installations of hydropower, and they have developed a Plotly plugin. So essentially, if you are building a more operator dashboard or something where you really want to control the layout of the data, Natel has taken this to an extreme. They actually implemented their HMI for their hydroelectric turbine in Grafana. So they run a Grafana instance on the edge device. They actually run it in a hypervisor on their real-time control system. And then they've written some, a bunch of server code that provides an API, HTTP API that Grafana instance accesses via JavaScript to turn the turbine on and off, and make actual adjustments to the real-time operating condition, which is on the far end of the integration spectrum, I think. But they committed that Plotly library to enable folks who want more control than just the default time series visualizations. And part of that is that they display a lot of data that isn't even time series in their system.
All right, cool. Thanks.
Yeah, so I was going to ask, so who's the target audience for the visualizations that you're preparing? Do you share that within the company, or do you also share it with clients or that sort of thing? Or
yeah, so I mean, a lot of what I just showed you is sort of some demo stuff we've been doing. Our main and some of the folks, I think there's some folks from Intellimation on the call. They're in sort of a engineering support role for the city of DC, and they use some of this data when they're diagnosing problems and want to see real-time data and historical data side by side. We have another interface that's completely custom that most of the end user technicians actually would interact with. And we don't develop, that's actually another software vendor provides that. But for us, we have a lot of dashboards. I didn't show many of these are all mostly around machine data, but we've got a lot of dashboards that are about the actual system operation. So we can show, how many data points we're getting in from a particular building alongside the health of the device that's ingesting that data from that building, CPU temperatures, all those operating characteristics of our platform.
Cool. Cool. Any other questions? All right, thanks. Yeah, that's a great example of utilizing another tool to take a look at the data and build off an existing platform. So thanks, Andrew.
Sure.
All right, Dustin, are you there? So kind of a different tack, but looking at the same data, and I'll turn it over to Dustin, maybe a quick intro about what the tool was developed for, and then go through the demo of what we found in the data.
Sure, sounds good. So my name is Dustin Arendt. I'm a visual analytics researcher at PNNL, sort of like an academic on the academic side. And so what I'm going to be talking about is a research prototype that we developed that was just recently published. I'll actually be presenting it next week at the Intelligent User Interfaces Conference in Los Angeles. And this is a tool, essentially an interactive machine learning tool. And it's called Chisel. And the motivation for this was not necessarily for time series data, but for the sort of problem with machine learning, which we've been talking about as like the elephant in the room, that you need a lot of high quality labeled data. And that's great if you can crowdsource it, but you can't always crowdsource labels for for your data. For example, if maybe there's only one person in the world that has the expertise to actually like look at something and say what it is. So we need other solutions besides crowdsourcing. And there's other techniques out there that that might work, but they're not completely satisfying. So there's like active learning, you might have heard of that. There's some problems with that. So our goal was to essentially come up with some type of interface that lets a user explore the data and create their own groups by example, while simultaneously training a machine learning model to predict what things belong in the groups that the user has created while they're interacting with it. And also, if we can predict what belongs in the user's group, we can actually start to help the user organize the rest of the data that they haven't looked at yet. And as they're doing that, and sort of like helping the user with this organization, the user might see that the machine learning model is making some mistakes and they can start to correct it. And so basically the contribution of this tool is kind of like the design of the interface, as well as a really fast, like a quick and dirty semi-supervised learning algorithm that helps bin things into the groups that the user has created. So this algorithm is designed to be really scalable. We've tested it on data sets of around 100,000 instances, and it runs completely in the web browser. And it's very space and time efficient. So we can get like real-time feedback from the model, repredicting on all of the data in a few milliseconds for data sets of that size. So it's basically instantaneous. So I'm going to talk a little bit about what you're looking at on the screen that I'm sharing right now. Hopefully everyone can see that. Let's see if there's something in the chat. Okay, no. And so what you're seeing is some VOLTTRON data that's been loaded into Chisel. And what we start out with is a sort of a summary of some different examples of data in the data set. So you can think of basically a clustering algorithm has run in the background in batch mode beforehand. And we're seeing some cluster centroids, basically. So we're seeing examples of some different data in the data set. And the idea is to just provide the user with kind of like a buffet to choose from, like whatever they're interested in, so they can see a diverse set of things to start out with. And one of our design requirements was that we never really aggregate the data. We're always showing raw examples. That way it's sort of grounded in the user's data, and it's a lot easier to visualize a single example of a piece of raw data than it is to come up with like a custom visualization that aggregates data in different ways. So for example, this tool works with text data and with images and with time series, and there's different ways of aggregating different types of data. But we decided we'll just show raw data. And so for any one of these things, we can click on it, we can see the full time series. That's great. One of the cool things that this tool does is it immediately provides this like plus button beneath all of these things, beneath all of these examples. And so we can see, for this particular shape of time series, there's another 452 things that are similar to that. So we can click that plus button and we can see some of the variability in that cluster. I'm not going to show you all 452, but you can browse through them if you want to see them. And you can see that they're pretty similar to that shape for the most part. Same thing for this one. This one is very different from the rest. So we can look at these and we can see that they're not all necessarily the same shape, but they do characteristically have like a lot of variability. So the algorithm is picking up on the variability of the things in this cluster. Okay. So that's where the user might start. I should mention that right now we're looking at zone discharge air temperature, but we've built models for a couple of different variables in the data set as well.
So,
yeah, go ahead.
How will we correlate that to other labels?
You mean like other metadata that we might have associated with the time series?
Mm-hmm.
Yeah, so let me start building groups and I'll show you how that works. So I can build a group by double clicking on an item, and basically double clicking on it creates a group from that example, and then it adds other things to that group that are similar. And I can essentially drag other things from the top that I think are also similar to that group. So I'll drag a couple more. And then let me add this one too, because that's quite different. And maybe this one is interesting too. And so it starts recommending things that belong to this group. And then to answer your question, on the right-hand side, we can see the distribution of other items or other variables in the data, categorical variables or time or whatever in the data set. So one of the things that we can see is like this group on the bottom here with this really weird like spike, tower-like spike in the middle, tends to happen in February and April, but not elsewhere. Whereas with other patterns tend to happen in the other months, but with increasing frequency. So this right-hand side shows you basically the distribution of whatever variable you want in the group that you've created. So I'm going to also just change the group names. So let me say tower spike or something like that. And I'll pretend I'm an expert. I'm not, but I'll say that this is a normal thing. And oops. Yeah, and I can label this one high variability. Yeah, and so basically I could, without necessarily knowing what I was looking for ahead of time, I can start to organize all the data. I'm going to go ahead and add all of the rest of the groups and then start to refine it a little bit. So we can see like this group on the bottom here, the example was this fairly characteristic peak, but there's this other one here that's very spiky, so I might double click on that to make a new group out of just that one, and then pull this original one back into what I consider normal, because it looks kind of the same, as well as this one's kind of interesting too. I really don't know how to characterize that one. Yeah, and so we can basically kind of repeat this pattern or repeat this process until we're sort of satisfied with what the model is giving us. And then once we're done, there's a couple of things that we can do. We can essentially export the data. So I'll go ahead and show you what that looks like. So I can click this download button, and it produces a CSV file. And that showed up in a different window, but here we go. So what we see in this CSV file is essentially the database ID of the time series, whatever label that we gave it, and then essentially a measure of the confidence of the model that that thing belongs in that particular group. And it's actually more of a distance, and so things that are closer to 0 are more confident. And you can actually see the ones, you can find the ones that you labeled if you dig through it and you look for a 0. This is a case where we actually labeled that instance, and so the confidence is maximal because the user actually labeled it directly. So you could essentially use this to build another classifier, like an inductive classifier that you could go and deploy on streaming data if you want, or you could use these groups that you've assigned to do some more post hoc analysis. You know, if you thought of other categories that you wanted to add later on. So let me see here. I mean, there's other stuff like the particular unit that this behavior is from, and so we can see like some of these time series, these shapes correspond to like most of the units, and whereas this one on the bottom corresponds to only a few, which is interesting. But I'm not a subject matter expert, I don't really know what the implications are.
Right. One of the things that we found reviewing this with some buildings experts was they could say, "Oh yeah, those are conference rooms," because their temperature is more variable than the office space because the doors opening and closing more often and that sort of thing.
Yeah, like perhaps this one with like all of the spikes is a conference room.
Yeah.
Okay. So some of the other things that we've done in this tool is we've actually integrated some of that like creation of the machine learning model like automatically in the tool. So like after you are done creating the groups that you want, you can actually hit deploy, and it will train the machine learning model and provide a REST API just as a proof of concept that you can throw new data at and get your classifications out of. Other things that you can do, which I won't demonstrate because it takes a little time to retrain, is essentially to relearn the representation of the time series data based on the groups that you've created so that it can better figure out what features help separate the groups that you've created. And so you can essentially do this iterative process where you create some first cut of your data. Maybe you organize things into groups that are interesting and not interesting, and then you like retrain it, and then you could delve a little bit deeper into things that you find are more interesting and repeat this as many times as you want. So that's basically it for what the tool does. Also point out that it's open source. So if you go to this URL, github.com/PNNL/chisel, you can get the source code. I should probably put a citation for the paper in here too. So if you plan to use it and then write a paper based on that, you can cite this. It's a research prototype, so it's not as easy to install as you would hope probably, but there are fairly good installation instructions if you're used to doing front-end development and a little bit of back-end development. You can follow these instructions. And it's based on MongoDB, so all of the data has to be put into a Mongo database for the tool to be able to be used. So any more questions about Chisel?
So like you said, this could be used to build up categories of devices and then give those to an expert and say, what does this mean, right? Like what are these, and is this what they should look like? It seems like this could also be used for some of the alerting type of work. The sensor suddenly starts giving readings that are totally out of character for whatever bin you've put it into.
Yeah.
And then you can also find the seasonal variation and other things that you could assign meaning to.
Yeah, I think that's a good summary of what you can do. I think you might also be able to do some anomaly detection. So if you use this map that you start out with, you can see that there are some points that are pretty far on the outside, and that just means that like the dimension reduction algorithm thought that they were pretty different from the rest of the data. And so you can find those examples like sort of more directly that way. So this one is pretty interesting. Not really see that pattern anywhere else in the data.
Huh.
Although some things that look anomalous, like this one, actually have a lot of representation in the data.
Right.
So it's, how do you define anomaly, right?
Right. There's some reason for that behavior.
Mm-hmm. Yeah, it looks like this. This pattern, the green one, seems to happen like with increasing frequency throughout the year. So maybe it only happens when it's hotter out.
Right. So which one is that? Can you click on that pattern? See the timeline. Discharge air temperature. Yeah. So it's all something to do with the cooling.
Yeah. Let's see. So you can separate it out a bit more.
So I'm curious. This is John with the Vista. I'm curious how how the window data is windowed.
Oh yeah, great question. So each one of these time series that you're looking at is a single day, and we window it. We bin it by hour, and then within each hour we calculate some statistics like the median value and like the variability and stuff like that. And the machine learning algorithm uses those statistics to, as input features.
Yeah, cool.
So yeah, so is anybody on the call using machine learning as part of their data analysis, or is that an area people are thinking of getting into?
I've used TensorFlow and image recognition before, so this is really interesting to look at what you're doing.
We're using, John here, we're definitely using image recognition as well. What I thought was unique here that you have is the ability to create a service so that you can automatically classify data coming in.
Mm-hmm. Yeah.
Does this turn into a pipeline, or is it really just a tool for exploring it to help you determine what you should deploy to operate long term?
Yeah, so being a research prototype, we didn't necessarily have the funding to engineer out a full pipeline, but we do envision it being part of a pipeline. The idea is that you have some data that is going to be streaming into your Mongo database where it's being collected, and then you might have, like at the end of the day, it's going to requery that data and rebuild a model or something like that. One of the other ideas was that you can, because it's so easy to build these models, you can kind of build one in the morning when you come into work, just like if you have an idea of what you want to look at, it's more of like a forensic tool. Build a particular model based on your hypothesis or based on what happened yesterday or something like that. It's very easy to pull out a subset of the data that you're looking at and build a model specifically for that using a Mongo query. So you can say, give me all the data for this particular sensor for the past 6 months, or you can say, give me all the data for this one building or something like that. If you can write a query, you can build a model on it basically. And then, so the output is then these groups, like once you've built a model, and then you can export that and basically have this REST API that you can run the new data through. And the idea there is that you might have something that is just enriching all of your data as it comes through with these tags, that you could use some other less sophisticated tool to organize the data like better, like maybe Tableau or something like that.
How tightly coupled are you to Mongo?
I would say not very tightly coupled, but there's a wrapper essentially that we have a REST API that goes between the front end and Mongo, and basically everything gets interpreted into like a Mongo query or something like that. But the code base is actually not very large, so it wouldn't be hard to just rewrite that wrapper for something like Elasticsearch or whatever backend you want.
So I dropped something in the chat. I don't know if you're familiar with it or not, but JPL has developed a tool they call Telemanom.
I haven't heard of this one. Yeah.
And they actually were here. They were in. It's funny. The guy who's presented this is someone I knew as a graduate. He was a graduate student at UT, University of Tennessee, and he's now at JPL. And they've developed this. It's really fascinating. It's a pipeline as a service to scientists across the JPL organization, and essentially you can push your data into it, and it will attempt to do anomaly detection automatically and apply some different pipelines based on what the data looks like. It is specific to time series, and then if if it does something you like or you think it's valuable, you can turn that into a ongoing processing pipeline that will generate alerts. And but it's the goal is to like enable folks to get value out of their data without having to learn. But this interface, like you guys, like I gotta like huge kudos. Like this is amazing.
Thanks.
This is such a great way to like build a UI for this. I'm really excited about playing with this some.
Yeah. Yeah. So it's open source, and you should be able to get like the demo examples running. Unfortunately, none of the VOLTTRON code or data is out there, but I think you might be able to work with Jeremy and us to get that to work if you're really interested in this specific use case. And then going back to the JPL anomaly detection thing, I think we could definitely leverage something like that. Our tool is pretty agnostic to the data, but it does require you to write custom visualizations and analysis pipelines. So it would be interesting to maybe plug in some more sophisticated anomaly detection tool like this one, which I see is based on LSTMs. So we could potentially extract some representation from that anomaly detection model and use that to better cluster the data.
Well,
and it might also, go ahead.
I said, if you're in LA soon, like shoot me an email. I'll connect you with. I already sent him your project link because it's just really cool.
Yeah.
So there might
I'll be in LA tomorrow.
Wow.
Timing.
Yeah. And so yeah, I'll probably have time around the conference if we want to meet and chat. I'll be like, I think in Long Beach, like near the airport. I know LA is like one city, but it's like it takes a day to get across it, right?
Yeah, when I was there a couple of weeks ago, it was just like, yeah, it does.
Okay. Yeah, and so I think something like this might also help with the segmentation problem. It's like what slice of the data do you look at? And we arbitrarily chose 1 day because we expected the patterns that we thought would exist were happening on like a 1 day time scale, but they could be at different time scales. So we made a lot of decisions to make our lives easier that are not necessarily correct.
Well, cool. Thanks. Any other questions at the time? And feel free to follow up with Dustin after this call. Let me put his email into the chat window here.
Let's see. And I'll also link the GitHub page.
Yeah, I already snooped on your tabs and found it.
Yeah, don't forget to put the source or your paper that you wrote on it out there as well.
Yeah, I will. I'll try and do that ASAP. Yeah, I don't know if I can put the actual paper because of copyright, but I'll definitely link to it to make it easy.
Okay. Yeah, and so I'm glad people are getting a lot out of this, because there's a whole group at PNNL that does visual analytics, and I'm hoping to see what other opportunities there are at PNNL and other places that have visual analytic tools that have maybe been developed for other domains and purposes, but if we apply them to buildings data, what can you do with it? So I'm hoping we can get some more presentations like this in the future as well.
I think I have some use cases in our university that aren't around building systems data that might justify investing some time building some wrappers around Elasticsearch, which is also what Telemon uses under the hood. So if there's some synergy there, like this would be a really cool tool for us for some of our streaming data architecture.
I'm hoping to get some funding for an Elasticsearch integration task.
Cool. Yeah, and I have
or for VOLTTRON.
For VOLTTRON.
Okay.
So I'm curious, like, why people are organizing around Elasticsearch instead of something like Mongo. So I personally find like Elasticsearch is super unfriendly, like to the user being like the person doing the querying and stuff. But
I think it depends on if you're a JavaScript developer or not. Like Mongo is really friendly to some degree if you're like really familiar with JavaScript, and it's just because your code is your like query language. But I don't think it's very friendly for folks who aren't familiar with JavaScript. And then the other thing, frankly, is that Elastic has just been putting a bunch of money into selling their machine learning pipeline. And so they're driving a lot of energy around it. And there's also the like lack of good horizontal scalability in Mongo, not arguing that Elastic's is good, but it at least exists and is open. Is also another thing where folks like JPL who are dealing with really huge amounts of data might choose a different solution. Elastic, one of the things that is difficult about Elastic is that while it's schemaless to a degree, once you start ingesting into an index, that index has got sort of a fixed schema. If you want to index things, you can add other things, but if they're, if you want them to actually be in the inverse search tree, like it's got to stick to pretty much the same schema. And so that's a little bit less friendly than Mongo, but what it means is it's really fast to query over huge data sets. Mm-hmm. And there's a lot better tools for sharding and partitioning too. Like, so for time series data specifically, they typically use a index pattern that like saves a day's worth of data per index, so that you only have to query the indexes that have data relevant to what you're looking for.
Now, does MongoDB provide any indexing capabilities like Elasticsearch? We can do like fuzzy logic and geospatial.
Yeah, I'm pretty sure it does. I think it's just not by default, so you have to say what you want to index on.
Yeah.
Yeah.
Okay.
And I don't know that Mongo has as rich a geo. Like Elasticsearch stores geolocations in a hash algorithm that is really efficiently allows you to bin geolocation. So if you are dealing with geospatial data, Elasticsearch has some really nice tools for that. It basically hashes the entire globe into, and you can set the resolution of the hash you want to look at, and it just makes it very fast.
Okay. Well, cool. Great discussion. Thanks, everybody. Any last comments? Okay. Like I said, I'm hoping we get some more visualization presentations in the future, because I think, we're collecting all this data, getting a handle on it and being able to get meaning out of it, I think is an important next step there. So if anybody else knows of, has a visualization or knows of something that they want to present around that, let me know. And I'll also be looking for other visualization researchers to bring on as well. All right. Awesome. Thank you, Dustin, and thank you, Andrew.
No problem.
Yeah, thanks for the opportunity.
Yeah, that was some great feedback. So thanks. Let me know if you want to follow up. Email either volttron@pnnl.gov or me directly, or Dustin's email or Andrew, and we'll be happy to have any follow-on conversations. And with that, we'll see everybody in a couple weeks.